Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P2, Variant 2, February March 2018. Let's get started. We eat more ice cream as the temperature rises. What type of correlation is this? Since the amount of ice cream we eat increases as the temperature also increases, then this type of correlation is positive. Write 0.0000523 in standard form. To write this number in standard form, we move the decimal point to a position after the first non-zero digit, which is 5. Since we moved the decimal point 5 units to the right, we multiply 5.23 by 10 raised to the power negative 5. Calculate square root of 17.8 minus 1.3 raised to the power 2.5. When we type this into the calculator, we get 2.29 rounded to 3 significant figures. Write the recurring decimal 0.8 as a fraction. Let's call the recurring decimal x. When we multiply x by 10, this is what we get. The values of x and 10x have the exact same pattern after the decimal point. So we subtract x from 10x and this is what we get. When we divide both sides by 9, we get x equals 8/9. The diagram shows a regular pentagon and a kite. Complete the following statements. The regular pentagon has blank lines of symmetry. A line of symmetry is a line that splits a shape into two mirror halves. Regular pentagons have 5 lines of symmetry. The kite has rotational symmetry of order blank. The order of rotational symmetry of a shape is the number of times the shape looks exactly like the original when it is rotated through 360 degrees. When a kite is rotated, it only looks like the original when it is rotated 360 degrees. So its order of rotational symmetry is 1. Factorize completely. 15k squared m minus 20m raised to the power 4. The terms have a common factor of 5m. When we factor out 5m, we are left with 3k squared minus 4m cubed. The diagram shows a regular hexagon ABCDEF. CD equals P and CB equals Q. Find CA in terms of P and Q, given your answer in its simplest form. CA can be expressed as CD plus DA. CD is P, DA is 2Q, so we have P plus 2Q. Newton has a population of 23,000. The population decreases exponentially at a rate of 1.4% per year. Calculate the population of Newton after 5 years. In this case, we need to apply the compound or exponential formula. Since we are dealing with a decrease, we bring a minus here. Big A represents the final population of Newton, which is what we are finding. Small a represents the starting population, which is 23,000. R is the annual rate, which is 1.4%, and T is the time duration in years, which is 5. When we type this into the calculator, we get 21,400 rounded to 3 significant figures. Find the value of P. 8 can be written as a base of 2, which is 2 cubed. In the denominator, the powers of 2 multiply, so 3 times 4 is 12. 1/2 raised to the power 12 can be written as 2 raised to the power negative 12. So now that the bases on both sides are equal, their powers must also be equal. So P equals negative 12. Y is inversely proportional to x. When x is 9, y is 8. Find y when x is 6. In mathematical terms, we write y is inversely proportional to x. We can rewrite this as y is equal to a constant, which we are going to call k, times 1/x, which is k/x. From here, we need to find the value of k. We can get the value of k by plugging in the values of x and y given in the question. This gives us 8 equals k over 9. When we multiply both sides by 9, we get k equals 72. Now that we have the value of k, when x is 6, y equals 72 over 6, which is equal to 12. Dev makes 600 cakes. 18% of the 600 cakes go to a hotel and 2/3 of the 600 cakes go to a supermarket. Calculate how many cakes he has left. To get this number, we subtract 18% of 600 and we also subtract 2/3 of 600 from 600. When we type this into the calculator, we get 92. Without using your calculator, work out 7 over 8 plus 1 over 6. You must show all your working and give your answer as a mixed number in its simplest form. The LCM of 8 and 6 is 24. For 7 over 8, since we multiply the denominator, which is 8, by 3 to get the LCM, we also need to multiply the numerator by 3. So 7 times 3 gives us 21. For 1 over 6, since we multiply the denominator, which is 6, by 4 to get the LCM, we also need to multiply the numerator by 4. So 1 times 4 gives us 4. So now 21 plus 4 gives us 25. 25 over 24 is an improper fraction, so we need to convert it into a mixed fraction. 24 goes into 25 one time with a remainder of 1, which we divide by 24. So we have 1 over 24. Solve the simultaneous equations. You must show all your working. First, let's label the given equations. We'll be using the elimination method. We want to eliminate x, so we multiply equation 1 by 3. This gives us 6x plus 1.5y equals 39, which we've labeled as equation 3. Then we multiply equation 2 by 2. This gives us 6x plus 4y equals 34, which we've labeled as equation 4. Now that we have 6x in equation 3 and equation 4, we can eliminate x by subtracting equation 3 from equation 4. This gives us 2.5y equals -5. When we divide both sides by 2.5, we get y equals -2. So now we can plug in the value of y into any of the equations to get the value of x. If we pick equation 2, we have 3x plus 2 times -2 equals 17. 2 times -2 is -4. When we add 4 to both sides, we have 3x equals 21. And when we divide both sides by 3, we get x equals 7. A, B, C, and D are points on the circumference of the circle. AC and BD intersect at X. Complete the statement. Triangle ADX is blank to triangle BCX. When we look at the two triangles, these two angles are vertically opposite angles, so they are equal. These two angles are subtended by chord AB, so they are equal. These two angles are subtended by chord CD, so they are equal. Since all the angles in both triangles are equal, then based on the AAA criteria, triangle ADX is similar to triangle BCX. The area of triangle ADX is 36 cm squared, and the area of triangle BCX is 65.61 cm squared. AX is 8.6 cm and DX is 7.2 cm. Find BX. For similar shapes, we know that the ratio of their areas must be equal to the square of the ratio of their corresponding sides. When we make BX the subject, this is what we get. When we type this into the calculator, we get 11.61 centimeters. Complete the statements. A equals blank because blank. These two are corresponding angles. Corresponding angles are equal, so A equals 63. B equals blank because blank. The sum of the angles in this triangle must add up to 180 degrees. So we have B plus 58 plus 63 equals 180. When we make B the subject, we get B equals 59. Find the area of triangle ABC. Here is the formula for the area of a triangle. We've been given the base B of the triangle to be 2.8 meters and the height H to be 1.6 meters. When we type this into the calculator, we get 2.24 meters squared. Calculate AC. To get AC, we apply the Pythagoras theorem to the given right-angle triangle. This gives us AC squared equals AB squared plus BC squared. AB is 1.6 meters and BC is 2.8 meters. When we plug in these values into the equation and make AC the subject, this is what we get, which is equal to 3.22 meters rounded to 3 significant figures. Solve the equation 2x squared plus 7x minus 3 equals 0. Show all your working and give your answers correct to 2 decimal places. When we apply the quadratic formula to the given equation, this is what we get. The numbers under the square root, 7 squared minus 4 times 2 times negative 3 gives us 73. For the denominator, 2 times 2 is 4. So for the first possible value of x, we get 0.39 rounded to 2 decimal places. And for the second possible value of x, we get negative 3.89 rounded to 2 decimal places. In this question, use a straight edge and compasses only and show all your construction arcs. Construct the perpendicular bisector of PQ. With our pair of compasses, we stand at point P. Open the compass to a width that is more than half of PQ and inscribe a set of arcs above and below PQ. Using the same compass width, we stand at point Q and inscribe another set of arcs above and below PQ. When we are done, we use a ruler to draw a straight line passing through the intersection point of the arcs. Construct the bisector of angle ABC. With our pair of compasses, we stand at point P and inscribe an arc for angle ABC. Then standing at this point, we open our compass to a wider width and inscribe an arc. Using the same compass width, we stand at this point and inscribe another arc. When we are done, we use a ruler to draw a straight line from point B that passes through the intersection points of the arcs. Use set notation to complete the statements for the Venn diagram above. C is a member of set X. The region X intersection Y contains the set of elements A, M, E. Y intersection Z equals blank. There are no elements in the region Y intersection Z, so we have a null set. List the elements of X union Y union Z complement. In other words, we are to list the elements outside the region X union Y union Z. The elements in this region are U, V, and W. Find n of X complement intersection Z. In other words, we are to find the number of elements in set Z that are not in set X. From the Venn diagram, we see that the number of elements in this region is 5. Describe fully the single transformation that maps shape A onto shape B. When we look at shape A and its image, shape B, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw a line to connect at least two corresponding points on both shapes A and B. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the point is the origin. And so the full description for the transformation is rotation 90 degrees anti-clockwise about the origin. Describe fully the single transformation that maps shape A onto shape C. When we look at shape A and shape C, we can tell straight away that this is an enlargement by a scale factor of 2 because each of the sides of the image, which is shape C, is twice its corresponding sides in shape A. We have a negative scale factor in this case because both shapes do not have the same orientation. Shape C is flipped. Now we need to find the center of enlargement, which we get by connecting at least two corresponding points on both shapes. When we do this, we get the center of enlargement to be 0,3. And so the full description here is enlargement by a scale factor of -2 about the center 0,3. Find f of 2. First, let's find f of 2. To get f of 2, we replace x in f of x with 2. This gives us 7 minus 2, which is equal to 5. So now to get f of 2, we replace x in f of x with f of 2, which we found to be 5. So we have 7 minus 5, which is equal to 2. Find g of f of x in its simplest form. To get g of f of x, we replace x in g of x with f of x, which is 7 minus x. So we have 4 times 7 minus x plus 2. When we expand the brackets, 4 times 7 is 28. 4 times negative x is negative 4x. When we group like terms, 28 plus 2 is 30, so we have 30 minus 4x. Find h of 2x in its simplest form. To get h of 2x, we replace x in h of x with 2x. So we have 15 minus 2x all squared. 2x all squared is 2 squared x squared. 2 squared is 4, so we have 15 minus 4x squared. Samira and Sonia each have a bag containing 20 sweets. In each bag, there are 5 red, 6 green, and 9 yellow sweets. Samira chooses one sweet at random from her bag. Write down the probability that she chooses a yellow sweet. This probability is equal to the number of yellow sweets in her bag, which is 9, divided by the total number of sweets, which is 20. Sonia chooses 2 sweets at random without replacement from her bag. Show that the probability that she chooses 2 green sweets is 3/38. The probability that the first sweet she picks is green is equal to the number of green sweets in her bag, which is 6, divided by the total number of sweets, which is 20. She picks a first and a second sweet. The end becomes times. After the first green sweet is picked without replacement, the pool reduces by 1. So the probability that the second sweet she picks is green is 5/19. When we type this into the calculator, we get 3/38. Calculate the probability that the sweets she chooses are not both the same color. One way we can go about this is to find the probability that both sweets are the same color and subtract from 1. In the event that the 2 sweets are the same color, then it means she either picks 2 red sweets or 2 green sweets or 2 blue sweets. The probability that the first sweet picked is red is 5/20. Without replacement, the probability that the second sweet picked is also red is 4/19. The probability that the first sweet picked is green is 6/20. Without replacements, the probability that the second sweet picked is also green is 5 over 19. The probability that the first sweet picked is blue is 9 over 20. Without replacements, the probability that the second sweet picked is also blue is 8 over 19. When we type this into the calculator, we get 129 over 190. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.